Okay, so here what we want to do is we want to look at this geometric series. How do I know it's a geometric? I have something raised to the n power from 0 to infinity. That's the telltale sign of a geometric series. I have something in parentheses raised to some n power. Now, what is different? We have introduced the variable x. We want to find all the x values for which this series converges. So in a way, we've turned our infinite series into potentially a function of x. Okay, so in terms of x, what values of x produce a series that converges? So first, to figure this out, I want to let a sub n equal the series, the sequence an, which is x minus 1 over 3 to the n, okay? Then we're going to run with the ratio test. What does the ratio test tell me? It tells me the limit as n goes to infinity of an plus 1, the nth plus 1 term, divided by the nth term, the ratio of those terms is equal to the limit as n goes to infinity, absolute value. What is it? It's x minus 1 over 3 to the n plus 1 divided by x minus 1 over 3 to the n. Okay? This is equal to, well, let's think about this. This part right here, let me duplicate, we'll do some scratch work down here. Okay? This part here is equal to x minus 1 over 3 to the n times x minus 1 over 3 to the 1. Okay? So what happens? This factor cancels with this factor, right? So what am I left with? I'm left with the limit as n goes to infinity of the absolute value of, well, just this piece right here, x minus 1 over 3. Okay, now, this has limit as n goes to infinity, and this in here has no n. So guess what this limit equals? It just equals the absolute value of x minus 1 over 3. That's it. Now, the ratio test tells me something. It tells me that the series n equals 0 to infinity, absolute value, x minus 1 over 3 to the n, converges if r is less than 1. Well, r here is this absolute value, okay? So that tells me if the absolute value of x minus 1 over 3 is less than 1, this problem is a problem that we can solve. This is equal to negative 1, and then less than x minus 1 over 3, less than 1. That's how we solve this. I multiply all sides by 3, and I get negative 3 less than x minus 1 less than 3. And then I add 1 to all sides, and I get negative 2 less than x less than 4. So x converges for values between negative 2 and 4. But what do we need to do? We must check the endpoints. We must check the endpoints. So what are the endpoints? Okay, the endpoints are negative 2 and 4. So how do we check them? So if x is equal to negative 2, then what happens? An, which was equal to x minus 1 over 3 to the n, becomes negative 2 minus 1 over 3 to the n, which is going to be negative 3 over 3, which is negative 1 to the n. Okay? And what do I know about that? Well, the limit as n goes to infinity of an is equal to the limit as n goes to infinity of negative 1 to the n. This thing diverges. Why does it diverge? Well, golly, if n is even, then it goes to 1. And if n is odd, it goes to -1. So I can create subsequences such that if you think about it, like if it started n equal to 0, that's 1, and then n equal to 1 is negative, and then 1, and then -1, and then 1, and then -1. It just switches back and forth, right? So I could take a subsequence of all the odd ones here, and by golly, what I'm going to have here, a subsequence of the odd ones, 2n minus 1, is equal to 1. And so that limits to 1. But if I take another subsequence, equal, and then I look at all the even ones are -1. So that subsequence goes to -1. The fact that I can go to two different answers looking at different subsequences tells me that this limit diverges. You don't have to prove this. All you got to tell me here is, look, hey, we know this is swapping between plus and -1. Therefore, it's not converging in on some limit. So since this limit diverges and it does not equal 0, then by the nth term divergence test, okay, the series diverges for x equal to -2. So this endpoint is a no-go. But what about this endpoint? If x equals 4, so if x is equal to 4, let's see what happens. Then what? A sub n becomes what? It becomes 4 minus 1 over 3 to the n, which is 3 over 3 to the n, which is 1 to the n. Okay? So 1 to the n, what's going to happen here? Limit as n goes to infinity of 1 to the n is equal to 1. Okay? Which does not equal 0. So by the nth term divergence test, the series diverges. Okay? If my terms are going to 1, at some point I'm going to be adding 1, 1, 1, 1, 1, 1, 1 infinite amount of times, and that's going to blow up to infinity. So the nth term divergence test tells us it diverges at both endpoints. So what does that tell me in summarization? So it tells me that the series n equal 1 or 0 to infinity of x minus 1 over 3 to the n converges for x such that x is between -2 and 4. Or another way to write this, x is an element of -2 to 4. Either way here, okay, either way I will accept that, but you just pick which form of how you want to write it and then go from there. Okay, so that's an example of things to come, so hopefully that makes sense to you. All right, guys, good luck.